I'm gonna name this one the Van Gogh.
Okay, so the part that we didn't get a chance to get to, that I skipped over so that we can get to the intersecting functions is basically sketching graphs. So today we're going to be looking at graphs. We're going to actually graph them ourselves. We're going to come up with equations of graphs as well. So you don't necessarily have to write this down. This is more for me kind of talking and guiding you guys through this. But when you are sketching graphs, okay, you got to use a little bit of inductive reasoning here. All right. If you're given the equation, of course, you know that you can go into your calculator, type it in, look at the graph, and pretty much copy it down onto your paper. Yeah. But when you're not given a function, you need to use the information that you are given to draw that quadratic. So, for example, this one I'll do with you, and then you guys are going to do some on your whiteboards on your own. So, you have to sketch the graph of parabola with the vertex at 1, 2, and a range of y is greater than 2. Now, right now, you know, pretty much all you know is the vertex, and you just know the range, and the range relates to your y's. You don't know which way the parabola opens up, or do you?
Yeah. Because if it's greater than or equal to 2, then it has to be opening up.
It has to be opening up. Again, because your range is greater than or equal to 2. So, to sketch this graph, we need a vertex at 1, 2. And then it needs to be a parabola that does open up. Because if it opens down, then technically the range would be everything less than or equal to 2. So we know that it's going to go up. And that will be enough to suffice for this graph. Okay? So you want to basically use what you're given, use a little thought here to determine, okay, well, if I'm given the vertex and the range, it has to open up. If I'm given the y-intercept and the x-intercepts, depending on where they are, it might open up or down. Okay? So like use all your pieces to help you there. So, yes?
It's if it's less than 2, then it goes down.
It would open down because then it would have been all the y values from negative infinity all the way to positive 2, no higher. Okay? So, whiteboards, I want you guys to sketch a few of these diagrams. Okay? This is your first one. We have our vertex at 1, negative 3, so we definitely needed that in there. And then it had x-intercepts at negative 1 and also positive 3. So think about it. The vertex either is going to be the highest point the graph can go or the lowest point. And the fact that the x-intercepts are above the vertex, that clearly meant that the graph had to open up and going straight through those values. So good job for the ones who held it up. Next one up. Yes, very similar to the one I gave you as an example. Negative 1, positive 2. The range this time, though, is less than, which means that I don't want the values that are bigger than 2. I want all the values that are smaller than 2. So, yes, it should have went down. Clear your boards. Here's the next one. Time. But, yes, if your axis symmetry is x equals 0, that means that the vertex has to lie on your y-axis. And on top of that, the range is everything less than negative 1. So it was on the y-axis at negative 1 going down. Some of you guys had it originally at 0, 0. But the range is based off of the max or the min. So the vertex is located there. Good stuff. Here's the next one. With this particular one, you have x-intercepts at 3 and 0. So 1, 2, 3, 3 and 0. And it says the range is greater than 1. If you think about it, talked about this last class. The vertex slash axis of the x-coordinate of the vertex, the axis of symmetry is located halfway between the x-intercepts. So halfway between 3 and 0 is 1.5. And then it says that the range is located at 1, or is everything less than 1. So it should have been halfway between at 1.5. Going through. Okay? Questions on this? Any questions up to this point? Sure. All right, a couple more. And a point here. And a point here. Even though these aren't x-intercepts, a parabola is symmetric. Okay? So its vertex, since these are basically on the same horizontal line, these points, equally between them is your axis of symmetry, and you had a maximum value at y equals 2, so it should have been at 2, 2, one's definitely probably the hardest of them all. You have a quadratic function that takes negative values between 2 and 5. What does that mean, you think?
The bravo's on the negative bravo.
Not,
Yes.
well, you're right about the negative part, but not the parabola being negative. It takes negative values between those two, so
Between x equals 2 and x equals 5, it goes below the y value of 0.
it's in the negative. So from here to here, it's going to be below.
This how it's like goes across the y-axis at 4.
What's that?
What does that 0 equals 4 mean?
The y is on the y, right?
Yes, think about it. When x is 0, y is 4. So that's a point 0, 4, which is the y-intercept, to let you know that it continues to go up.
Wow.
So basically the negative values don't mean anything.
No, the negative values basically let you know that the parabola is going to be below the x-axis between 2 and 5 only.
Oh.
So then that lets, and then of course the y-intercept is above those two values, which means it had to go above to cross here. It couldn't have been pointing down because then it would have been below in places other than between 2 and 5. Does that make sense? Questions on just the sketching from this information? Okay. Well then let's look a little bit more to some detail. Yes.
The function that 0 plugs into what function is that?
It could be.
Because it says that when 0 is plugged into the function, it equals 4.
Right.
But
So you know that your C would have to be 4.
okay.
But then what type of function would do that where it's only between 2 and 5? Off the top of my head, I can't think of one. But we probably could come up with a couple of different ideas for them.
I learned like do I just
Andrew, C is the only variable that's not connected to its x, so everything else will be multiplied by 0. It doesn't matter what the function is, it's still equal x.
Yes.
what about
Non-existent. All right. So now we're going to look at finding equations given the graph, okay? So, when finding equations of a quadratic function graph, okay, basically we're looking at a couple of different things. We need to see if we have a y-intercept, or if we have the axis of symmetry, or we can determine what the axis of symmetry is by looking at the graph. We have a vertex. That also works as well. Maybe even some x-intercepts, okay? But if we have any one of these two things, that is definitely a plus. That's like the top two you want to look for, because it makes things a little bit easier. Okay? So what we're going to do, everybody has a sheet of paper, yes? We're going to look at these two examples. The first one is one in general, just of writing an equation of a quadratic. The other one is an actual IB exam 2013 question. Okay? So, we're going to find the equation of this graph. Looking at this, we have a few pieces of information. What can you pull out? And maybe not up here on the screen, but definitely on your paper that's in front of you.
The vertex. The vertex is the negative.
We got a couple things. We got a -2,
X equals.
x equals -2, so the axis of symmetry does cut through there. Are you sure?
yes.
Okay.
Not 1,000%.
Not 1,000%. I don't know. Let's kind of put a question mark beside that one. We definitely know for sure though that x equals -2. What else?
Well, it cuts it in half
Mm-hmm.
equally, so it'd be 9 the way the numbering system goes, wouldn't it?
Yeah, like how can we not know that that's the vertex?
It is the vertex, yeah. But do we know for sure that this is exactly at 9?
Well, how do we know for sure that that's at -2? It could be like slightly off. Like it's the same thing.
Yeah. So you read.